Because I cut my finger and I
Alright, so first thing in my notes on slope that I'm going to deal with is the formula. The formula for finding slope. We know that the symbol for slope is m. I do not know why, it's just what it is. M is equal to what I get when I subtract my y's divided by what I get when I subtract my x's. Y's on top, x's on bottom. That's because another way of writing slope is rise over run, and y's are your up and down, x's are your over. So changing your y's on top, changing your x's on bottom, that is our slope. So if I gave you 2 points, -6, 9, and 3, -5, and asked you to find the slope, you actually have options. If you've got some good graph paper that's evenly spaced, and I didn't draw, so it's evenly spaced and you could use it well, you could graph those 2 points and you could count rise over run. You could do that. Other thing to do, it's going to be quicker and easier for me on this one just to use my formula. This one would be my x1, y1. This one will be my x2, y2. Now, it doesn't really matter which one you make your 1 and your 2. And y'all know this is to review stuff, but if I wanted to make the -6 be my x2, I could do that as long as I made the 9 be my y2. Ones have to be in the same order paired together, 2's have to be in the same order paired together. Other than that, it doesn't really matter which one's which. Alright, so I'll get ready to do my subtraction. Y2 minus y1 over x2 minus x1. Now make sure you keep them consistent. On the top, since I chose -5 first, I had to use the one that went with it first on the bottom. Okay, it's the only real rule on that. Stay consistent on it. So that gets me -5 minus 9 is -14. And 3 minus -6 is 9. That won't reduce, so my slope is -14 ninths. A lot of times when we want to write slope as a decimal, it's actually, unless the problem has to do with money or something like that, where it's a decimal, it's better to leave it as a fraction, because remember, it means rise over run. Okay? So you right now on your own find the slope of the line that goes through 2, -1 and -5, 3. See if you can find the slope that would be that line right now. Go. Alright, Scout, what'd you get for your slope?
4 over -7.
Okay, now, the way Scout said that is fine, 4 over -7. Did anybody say -4 over 7? Could say that way. Did anybody put the negative out in the middle? Could do that. What you need to know on that, this is the same as if I wrote it that way or if I wrote it that way. As long as you only have one negative in there, it can be in any of the spots. Okay, so all of those are correct. Good job. The plug in on that, I would have done 3 minus -1 over -5 minus 2. So that got me 4 over -7. Good job, Sir Pugh. Everybody good on finding the slope? Alright, now let's look at an equation. I got 3x minus 4y equals 12. And the directions ask for the slope of that. Now we're going to get into later on how to rewrite that into slope-intercept form, y equals mx plus b, where it tells you the slope. But for right now, we're not going to do that. That's in standard form, ax plus by equals c. So we're going to use what we did yesterday. Bless you. We're going to use what we did yesterday to get a couple points out of that. When we were in standard form yesterday and I told you to graph a line, what did you have to find? The intercept. So I can do that same thing here. I can get my x-intercepts and my y-intercepts, and then I can use those 2 points to find the slope. Okay? So I've got it set up there with the x equals 0 on top, be my y-intercept. So if I plug a 0 in for the x, 3 times 0 is 0. So it's just going to leave me with negative 4y is equal to 12. So it gets me y is negative 3. So there's 1 point. So now I've got an x1 and a y1, but I got to finish this one down here to get an x2 and a y2. I'll plug a 0 in for the y. 4 times 0 is 0. So that just leaves me with 3x equals 12. Good job. So I got x equals 4. So there's my x2 and y2. So we had a little bit more work, but now we're to where the last problems were, and it's actually a little bit easier because it's got zeros in it, so we're subtracting with zeros. I set that up. I got y2 minus y1 over x2 minus x1. 0 minus negative 3 is 3. 4 minus 0 is 4. Release. Alright, we talked yesterday about special slopes. Just remind you real quick of some different things. Let me pretend I'm fancy here for a little bit. Make these be a different color. Alright, so I've got 4 lines graphed there. Let's look at line number 1 here. Line number 1 is going, if I read, and I read in math the same way I read in English or any other subject from left to right. So in line number 1, if I start on the far left of it and I start reading, and I always say I'm riding my bike on it, would I be going uphill or downhill on this line? Downhill. So since that line's going downhill, all I want you to know right now is it's a negative slope. Okay, line number 2, I'm going to call this one line number 2. Left to right, I'm riding my bike uphill. So if I'm riding uphill, that one is a positive slope. Okay, then I've got 2 other ones there. This one, I'm not going up or downhill. Just straight, flat as can be. Might as well be like riding in Kansas or something. What's the slope on a line that's horizontal?
The white line.
0.
0. Slope on a horizontal line is always 0. And the reason why, and this is always cool to me to look at it, if I pick, because remember we talked about slopes rise over run. So if I pick 2 points on that line, see those 2 that I just dotted, and I counted rise over run, to get from this dot on the left, this point on the left to this point on the right, how many do I go up or down? 0. So that would be 0 over, and then I ran 1, 2. So 0 over 2 is 0. 0 divided by anything is 0. So horizontal line never has a rise. Its rise is always 0. That's why that works out that way. Okay, which means on this crazy thing, okay, first off, imagine how am I going to ride my bike on that line? I mean, I rode, pedaled uphill, coasted downhill, straight land. What is this thing? I mean, I better be brave and get some protective gear on if I want to be riding that. What's the slope of it? Undefined. Same story as on the 0 line. If I pick 2 points and counted rise over run, that rise is 1, 2, right? But how many does it run? How many does it go over? 0. So vertical lines are always going to have a run of 0, and you can't divide by 0. 2 divided by 0. Anytime 0 is on bottom, it's always undefined. Okay? Alrighty. Woo. Check, we did that. Horizontal and vertical, we did that. Alright, next thing, what? All of our lines so far, I've been telling you, but just to make sure you know, all of our lines so far have been in standard form. We got our old Algebra 1 buddy of slope intercept, which is mx plus b. There was also one that was not used as often, but it was called point slope. Look like that. Alright, so I gave you that 3x minus 4y equals 12. That one we did a little bit ago. I gave you that one and asked you to find the slope, and we did that by finding the intercepts. Another thing we can do when it's in standard form to find the slope is rewrite it in slope-intercept form. So that's what we're going to look at right here. If I have 3x plus 4y equals 9 and I wanted the slope. Okay, now we did that exact same type of problem earlier where we found the intercepts and used the slope formula. That will still work. You can still do that. But just telling you now, another way to do it would be to write it in slope-intercept form. In slope-intercept form, you just need to solve for y. So I need to get the y by itself. So first thing I would need to do would be to get rid of 3x. So I'm going to subtract 3x from itself and from the other side. So cancel out there. It would leave me with 4y equals. Now, before I write this, in slope-intercept form, the x usually comes first. So I want to keep everything in that order. So I'm going to write my negative 3x first. It's not wrong if you write 9 minus 3x, but then it's just harder to match your pieces up. Okay, now I'm trying to solve it for y, and it's being multiplied by 4. Divide by 4, and when I divide this other side by 4, I got to divide both parts. So that'll cancel out. That'll give me y equals negative 3x divided by 4 is just negative 3/4 x. 9 divided by 4 is just 9/4. So I've got it solved for y. It's in slope-intercept form. Do I know what its slope is now? Slope would be negative 3/4. Where would it cross the y-axis? That's what the b stands for. Where would it cross the y-axis? At 9/4. That's your y-intercept. You remember that? You know, wow, Algebra 1 kids are usually good at that stuff. Alright, we're going to graph a line now. So, since I've got my graph paper ready, let me throw it in. We're going to graph a line that goes through the point negative 3, negative 2, and has a slope of 1/2. So that's all they give me. They say you're a line, you go through that point negative 3, negative 2, and you have a slope of 1/2. Alright, so first thing we need to do is find that point. So negative 3, I'm going to count on my red ones, left 3, negative 2, down 2. There's my point, found that. Now from that point, I have a slope of 1/2. Remember, that means rise over run. So for every 1 I rise, I have to run 2. So here I'm going to start from the point, rise 1, run 2. Rise 1, run 2. How many times do I have to do this? Just enough so I'll get a good idea of where to draw my line. You can also go the other way. If I want to extend the line to the left to make this still be a positive slope, wouldn't it be -1 and -2? Because the negative by negative is positive. So I could go down 1 and left 2 to extend it the other way. Down 1 and left 2. So we got a pretty good line there. Ooh, a red line. Isn't that a bad sign if you're in the hospital and you see a red line? Or that's a flat line. That's what that's called, right?
That just means you have a really big heartbeat from that.
That's good. Good thing. Maybe.
I don't know.
Sydney's like, oh, you're gonna die. That's funny. Good thing I'm not what? Sometimes I go. Yeah, sometimes I go and play my guitar for people in the hospital. They like it. They don't know I'm not any good. I might celebrate when I leave. All right, everybody good on that? That's easy stuff. Now, parallel. Symbol for parallel, I've got it over there on the dry erase board. Symbol for parallel is 2 parallel lines. Symbol for perpendicular is your upside down T like that. That's parallel, perpendicular. What do we know about slopes of parallel lines? They're never going to intersect. Their slopes have to be. Thank you, Caleb P. Slopes are the same. Okay. What about the slopes of perpendicular lines? They form a 90-degree angle when they intersect, so they're not the same slopes. There's 2 things. One of them starts with an R.
Reverse.
Close. Reciprocal. Good. The other one has to do. Good job. The other thing has to do with their signs. Opposites. So the slopes are opposite reciprocals. I don't know how to spell reciprocals. I'm looking. Anybody know? RECIPROCALS. Alright, so then I've got over there on the dry erase board on the bullets it says parallel, perpendicular, or neither. What would neither look like? I mean, there's nothing special about their slopes, but what would if parallel lines are never going to intersect, their slopes are the same. Perpendicular lines intersect at 90-degree angles, their slopes are opposite reciprocals. If I got 2 lines that are neither of those, what does that mean they do?
They make an X.
They just intersect somewhere, but not in a 90-degree angle. Good job, Blake and Austin, on that. So they would just intersect somewhere, but not on a 90-degree angle. All right, so talking about perpendicular and parallel, I've got a line that goes. Through the points -1, 2, and 3, 5. So one line goes through those points. Then I got another line that goes through 4, 7, and 8, 10. The question says, are those lines parallel? So for me to know if they're parallel, it's just a yes or no. If they're parallel or not, I got to know if their slopes are the same. If their slopes are the same, yes, they're parallel. If their slopes are not the same, no, they're not. So we got to find the slopes of both of those lines. So this is back to the original thing we did. You ready? Subtract my y's. Subtract my x's. 5 minus 2. 3 minus -1. So that first line would have a slope of 3/4. Questions on that? Alright, I already can tell the answer. Can y'all?
Nope.
Let's go ahead and finish it. Subtract my. So y'all are funny fellas. Subtract my y's. See what's 10 minus 7. Subtract my x's. See what's 8 minus 4. So I got same slope. So are they parallel? Yes. I wrote a big old yes there, Louise. Alright, now I'm going to give you 2 equations. I got 3x plus 5y equals 6. 5x minus 3y equals 2. This time the question says, are the two lines parallel, perpendicular, or neither? So we got to decide, and we got to do that. It's all based on their slopes. So what you've got to decide now is, how do you want to find their slopes? And some of y'all have already started. Do you want to find the intercepts?
Yeah.
Okay, y'all all right to do what Austin said? The other option would be solving them for y and putting them in slope-intercept form.
Oh,
Blake wants to do that.
I don't care about
That's what
that.
I would do. That's what I would do.
What is it?
All right, I'm going to solve. I think Austin got outnumbered. So I'm going to subtract 3x from this first one. Gives me 5y. Remember, in slope-intercept form, the x comes first. So negative 3x plus 6. Then I would divide everything by 5. So it gets me y is negative 3/5 x plus 6/5. So the slope of that first line is negative 3/5. Okay, because that was what was in my M spot. Everybody okay on that? Okay, now I got to solve the second equation for y. So on it, I'm going to be subtracting 5x from both sides. So that gets me negative 3y equals negative 5x plus 2. Divide by negative 3. Negative divided by negative right here is positive, so that'll be 5/3 x. And then positive divided by negative is negative 2/3. So this one has a slope of 5/3. So I know automatically they are not the same. So these lines are not parallel. To be perpendicular, they had to be opposites, negative and positive. That's good. And they had to be reciprocals. Is 3/5 the reciprocal of 5/3? Yes, so those lines are perpendicular. What if it had been negative 3/5 and negative 5/3? What would they? Which one would I have chosen?
Neither.
Neither. Very good, Mr. Blake. Alright, the last thing that we've got, your last bullet up there says solve problems involving rate of change, average rate of change. I know that's hard to read, that's messy. Solve problems involving average rate of change. Average rate of change is the same as slope. So anytime you see rate of change, that just is another way of saying slope. A lot of people don't realize that. And these are going to come, this is a word problem scenario that I got here. Okay, this one is about some teenagers' bad habits. Here it says in 1997.
Backer.
Yep. In 1997, 36, this is big, 36.4% of high school students smoked. So in 1997, 36.4% of high school students smoked. In 2003, 21.9%, so it's going down. 21.9% of high school students smoked. It says find the average rate of change in percent per year. Okay, so first thing before I get started in this, and this just sets up as a normal slope problem when it asks for average rate of change. I see that the the percentage of high school students that are smoking is decreasing. So would I expect my slope to be a positive or a negative? Negative. My line will be going downhill that I'm riding my bike on, so it will be a negative. So I've got here my x1 and my y1, my x2 and my y2. So I'm going to say 21.9 minus 36.4 over 2003 minus 1997. I don't, anybody got a top negative number for me? Negative 14.5, and then how many years between those? 6. Okay, so this is a time where we're actually going to divide that because we're putting this as a percentage there. So when we divide that, it would be negative what?
I'm gonna put negative. 4167.
2.4,
It would be negative.
2.4, I'm gonna go with. So that would mean that each year, in context of this problem, each year, the number of high school students that were smoking decreased by 2.4%. Now, dilemma, most of the time we rewrite percentages as decimals so we're a little confused on whether or not to change that. But since I kept these as whole percentages, my answer came out as a whole percentage. So we didn't have to worry about that. Okay?
Yeah.
Well, I hope so.
They're not.
Katie, that is not true.
You know what I mean? Because I know a lot of people that smoke and they're my age, so
Well, they would be in that.
they're killing brain cells.
So could we figure out?
Everything kills brain cells.
Could we figure out what 2016 would be?
Oh yeah.
How could, let's see, this would be, it's my X and my, I don't know, how would we do
We
that?
don't have to know.
But we've got negative, my slope, negative 2.4 is equal to y2 minus y1, check it out, over x2 minus x1. Okay, so negative 2.4 is equal to x minus 21.9 over 13. Is that right? 2016 minus 2003 is 13. Okay, so now my x being divided by 13, so I'd multiply by 13. So what's negative 2.4 times 13? Negative 31.2 equals x minus 21.9. So I would add 21.9. This is telling me that nobody, based on that trend, there would be no smokers. Because that's a negative, and you can't have a negative person. So,
That is
yeah. I mean, that would be based on that data that was collected in 1997. All right. They were just having some fun on that, trying to figure out what it would be nowadays, and they got a negative number on that, which would mean if that trend continued that started in 1997, that at some point there would now be 0 high school students that smoke, but that trend is probably not continued at this point. All right. Everybody good on slope? I feel like you ought to be. Slope's something you've been doing for a while. Tomorrow's stuff goes just more equations, so it does get into a lot of the slope-intercept form, which we already introduced today. Just gets a lot more detail with slope-intercept form. Look it up.